So today we're going to continue on with the topic of algebra, and now we're moving on from looking at just expressions and using those rules that we learned for expressions. We're now going to look at how we solve equations. The work we did on expressions, it's important to watch those videos, is largely the foundation of what we're going to be doing here and will help us significantly. I'm going to start off with how we solve basic one-step equations, and even looking at these, you're probably going to think, well, they're incredibly easy. I'm not trying to insult your intelligence. I'm trying to get us into a way of how we set our working out. Because as we progress to two-step equations, equations involving brackets and equations where we have x's on both sides, which I will look at in further videos, it will become more difficult. So starting off with the most basic of equations. So if you remember the difference between an equation and an expression, the expressions that we were looking at, what made them expressions was that they didn't have an equals, and therefore they couldn't be solved. They could only be simplified or written in a different form. These are equations because they have equals and therefore they can be solved. And we talk about solving something, we mean that we can find the unknown letter. So if we think about what this means, a plus 2 equals 3. So this means something plus 2 equals 3. And even just saying that something plus 2 equals 3, we'll very quickly go and work out what the answer is going to be. The only thing something plus 2 equals 3, the only thing that something can be is 1. So a is going to equal 1 in this. However, I want to get you into the habit of how you would set your working out in an exam when we're looking at trickier questions that involve more than one step. When we are trying to find an unknown value in an equation, what I want to do is I have a plus 2 on the left hand side of the equation and 3 on its own on the right hand side, and I treat the equals as the middle of the equation. I treat the equals like a set of scales. So if we're going to imagine a set of scales, and scales are balanced, okay, and we want to keep them balanced, okay, so we want to keep them in that way. If I take something off one side, the scales will become unbalanced. So what I do is I have to do the same on both sides. So in solving an equation, what we're trying to do is get the letter on its own. The letter we're trying to find in this case is a. So what I want to do is I want to get it on its own on the left hand side. So what I need to get rid of is the plus 2. Now how I get rid of plus 2, I take away 2. So generally the rule is that if we're trying to get rid of something, we use the opposite operation. So to get rid of a plus 2, we subtract 2. So to get rid of this plus 2, I subtract 2 from the left hand side. Okay. However, if I'm taking away 2 from the left hand side, the scales will become unbalanced. So to keep them balanced, I have to take away 2 from the right hand side as well. Okay, so I always set my working out with equations in lines, one after the other. I haven't done anything with the a. The a is still there. The a is what we're trying to find. Plus 2 minus 2 is 0, so it's gone. The plus 2 is gone. Is now equal to 3 take away 2, which is 1. And again, that's just how we would show working out. You don't need to draw this little set of scales, but these circles I've shown here with the operation that we just carried out is what I would be showing. Okay. Equally, if we look at our second example, b take away 4 equals 2. Okay, so what I have with the b on the left hand side is this subtract 4. So to get rid of a subtract 4, I add 4. However, if I add 4 to the left hand side, considering minus 4 plus 4 is 0, so that's going to be gone, the scales will be unbalanced. So what I have to do is I have to add 4 to the right hand side as well. So now what we're left with, we've got our b. Plus 4 minus 4 is 0, so it's gone, is equal to 2 plus 4, which is 6. And again, you use substitution to check your answers in algebra when we're solving equations. It's handy as well. So if b is 6, 6 take away 4 equals 2. That makes perfect sense. Okay? Now, again, if we consider the previous videos that we looked at, multiplying terms in algebra, our rules of indices and so on, and those types of videos, if you have a wee recap on those, 3c equals 12. When we see a number and letter beside each other like this in algebra, it means this operation here is multiplying. We don't need to see 3 times c. 3c means 3 times c. So this 3 is multiplying here with the c. So to get rid of the 3, I have to do, if you remember, the opposite operation. The opposite of multiply is divide. So I'm going to divide by 3. If I divide by 3 on the left hand side, remember I have to do the same on the right hand side also. So 3 divided by 3 is 1. So 1c. And again, if you remember in algebra, we don't really need to write 1c or 1d or whatever it is. We can just write the letter itself. 12 divided by 3 is 4. And again, that makes perfect sense, because if c is 4, 3 times 4 does in fact equal 12. Okay? Moving on to our fourth example. And again, this is the way you will see this commonly shown in an equation in an exam. The line in a fraction, remember, it's called the dividing line. So this means divide, this means d divided by 5 equals 2. Okay, so working backwards from that, doing the opposite. The opposite of divide by 5 is multiply by 5. I have to do the same then on the right hand side to keep my equation balanced. So d over 5 times 5 is just 1d, which again, remember, we just write as d is equal to 2 times 5, which is 10. So that is how we do the reverse of our 4 operations to solve equations when we're dealing with one-step equations. Okay? Using these rules, this is going to help us now when we look at two-step equations. Now again, you might look at these and think, well, God, they're very easy. Again, I'm not trying to insult your intelligence, but this will help us as we start to look at trickier types of exam questions. But again, you'll very easily see these in an exam. We are working backwards. We are getting rid of what's on the left-hand side to find the unknown letter. So if we look at our first example here, when we're dealing with two-step equations, we've got 2 times something plus 4 equals 18. And even when we say it that way, we can probably work out in our heads what that is going to be. All right? Not be as easy when we're dealing with equations that involve brackets or x's on both sides. So just keep that in consideration. When I'm working backwards, I'm going to get rid of this plus 4 first. Okay? If I consider what's on the left with the a, I've got to multiply by 2 and a plus 4. I'm working backwards, so I'm going to get rid of the plus 4 first. So to get rid of plus 4, I subtract 4. And I do it. Two-step equations, there's going to be 2 steps to solve it. Okay? Remember, I have to keep my equation balanced. So if I'm taking 4 away from here, I have to take away 4 from the right-hand side as well. So I'm left with 2a plus 4 minus 4 is 0, so it's gone. 18 take away 4 is now 14. Alright, so now I have 2a equals 14. I now have to get rid of this 2. So remember, this 2 is multiplying with the a. The opposite of multiplying is dividing. So divide by 2. I have to do the same on the right hand side as well. So 2a divided by 2 is 1a, which is just a. 14 divided by 2 is 7. Okay, and again, if I wanted to check my answer, I can substitute the 7 back into the original equation. So 2 times 7 is 14 plus 4 equals 18. That makes perfect sense. Alright, moving on, similar type of question. I need to get rid of this multiply by 3 and the take away 5. I'm working backwards, I'm going to get rid of the take away 5 first. So I add 5, do the opposite, but I have to add 5 to the right hand side as well. So now what I'm left with is, I haven't done anything with that 3 yet. 3b minus 5 plus 5 is 0, so it's gone. 10 plus 5 is 15. So now I have 3 times b equals 15. So to get rid of 3 times, I divide by 3. And I do the same on the right hand side as well. Again, this is just using the rules that we learned earlier when we were dealing with one-step equations. So 3 divided by 3 is 1, 1b, which is just b. 15 divided by 3 is 5. And again, substitute back in just to check. So if b is 5, 3 times 5 is 15. Take away 5 equals 10. Makes perfect sense. Alright. The next one, we have a division here. So we've got c divided by 3, take away 2 equals 2. So I'm going to work backwards and get rid of this minus 2 first. So I add 2, I add 2 to the right hand side as well. So haven't done anything with this 3 yet, so I'm still left with c divided by 3. Minus 2 plus 2 is 0, equals 2 plus 2, which is 4. Alright, now I've got c divided by 3 equals 4. To get rid of divide by 3, I multiply by 3. Multiply by 3 on the right hand side as well. So that leaves me with c over 3 times 3 is c. 4 times 3, which is 12. Okay, and again, let's just substitute back in to check our answer. 12 divided by 3 is 4. 4 take away 2 is 2. Alright, now I'm going to cover one more example. Just something to keep an eye out for is, again, it's another two-step equation, but it's just when we have this type of operation. Okay, so d plus 2 divided by 3 equals 4. Okay, so because we're doing d plus 2 and then dividing by 3 again, we're working backwards. Because we were dividing by 3 last off there, we're going to get rid of the 3 first. So unlike this question, okay, just see the difference in the way they are written. Instead of get rid of the minus 2 first, which we did here because it was the last thing, we're going to get rid of the divide by 3. Okay, so we get rid of the divide by 3 first. So you divide by 3, we multiply by 3. And we do the same on the right hand side also. Okay, so d plus 2 divided by 3 times 3 gets rid of that 3 in the bottom. So I'm left with d plus 2 equals 4 times 3, which is 12. Now all I have to do is get rid of the 2. So d plus 2, I take away 2. I do the same on the right hand side as well. So I'm left with d plus 2 minus 2 is 0 equals 10. Okay, now again, let's just substitute back in to check our answer. 10 plus 2 is 12. 12 divided by 3 is in fact 4. So again, that works. Alright, so hopefully these examples will help you with the questions I'm going to put at the end of the video. Again, like anything in maths, plenty of practice is how we improve. Anything you're unsure about, just feel free to ask.